Welcome to the next video in the Boomerang 2D tutorial series. This time we're going to talk about actors and the Actor Studio. Actors are the most complicated feature of the Boomerang 2D framework, which is why we're going to tackle it first. Once we understand actors, everything else is going to be pretty easy. So let's go ahead and dive right in. We're starting with the project that we set up in the Getting Started video, and so we have the demo content already installed, but we haven't created any of our own content. What we're going to do in this video is open the Actor Studio, and then we're going to create a new actor, and I'll show you how it all works step by step. We'll also flip between the actor that we're creating during this video and actors that have already been created to show some more examples of how things can work. To get started, go to Tools, Boomerang 2D, and down to Actor Studio. Let's dock it here so that we have a lot of room to work with. To start, we have some icons along the top. We have the plus icon, which allows us to create a new actor, a drop-down list, which allows us to select an existing actor, and a reload button, which allows us to refresh the editor if we make changes in another editor. For now, let's go ahead and create a new actor. We'll name this Tutorial Player and choose Create. Now this drop-down box will include our tutorial player that we've just created. On the left are some tabs that allow us to configure the different properties, bounding boxes, particle effects, and so on of our actor. We'll start with the first tab, Actor Properties. Since this is going to be a player actor, we're going to check this box that says Is Player Actor. This has various effects within the Boomerang 2D framework, however the primary effect is that this is the actor that the camera will be focused on. If you have multiple actors that have this flag checked, the last actor added to the scene will be considered the official player actor. We also have a section here called Obeys Chunking. In a future video, we'll look at how maps work and how chunking works within those maps. The general idea, though, is that your map will be divided into chunks of tiles. As your character moves across the level, those chunks will be activated and deactivated. Obeys Chunking is a flag that tells the actor whether or not to activate or deactivate if the containing chunk is active or not. For the most part, we don't want our player actors to obey chunking. The reason for this is if our player actor ever goes off of the screen, we want it to not deactivate. We want it to stay active. For example, if you jump too high and go off the top of bounds of the camera, we want it to actually come down at some point. If it obeys chunking, it will deactivate once it goes off screen. So we'll go ahead and uncheck this for our player actor. Here we have a sprite width and a sprite height. We're going to import a tile sheet, and it will automatically slice that tile sheet according to these widths and heights. The tile sheet that we'll be using is a copy of the one that we've used for the demo content. However, I've given him a green sweater instead of a dark blue one. We can see that each cell of our actor sheet is 48 pixels by 16 pixels high. And so we'll go ahead and enter those properties in. 48 pixels wide and 16 high. Now it'll ask us to import the tile sheet. Now, if we go over to Actors, and we expand this out, and we go down to Tutorial Player, we'll see that we now have a JSON for our tutorial player and a sliced up sprite sheet for that player. The next tab down is our state machine. Right now it's blank, and we'll visit this in a moment. The next tab down is our bounding boxes. Bounding boxes allow us to detect when our player character is overlapping other actors and whether or not it can stand on solid platforms. Let's go ahead and add one bounding box. We'll see that we have a size, and this is in pixels. We know that our main character is 16 by 16 pixels inside of a 48 by 16 high space. So we'll set our default size to 16 by 16. We'll also give it an offset of 16 in the X and 0 in the Y. This next section are the default flags. Flags give us more control when determining how this actor should react with other actors' bounding boxes. For example, you may have two types of enemies, one that can be jumped on and one that cannot be. In that case, we would add a flag to the enemy that can be jumped on as jumpable, and a flag on the enemy that can't be jumped on as unjumpable. Then we can use the value of these flags when colliding with another actor to determine the outcome of that interaction. You can also have multiple flags. For this, we'll include a player flag as our default flag. These next section are rays that we cast in the 4 different directions. Rays are important because they determine the collision with the environment around them. For now, we're going to set each of these values to 2 with a ray length of 2. We'll set 2 rays to cast with a 2 ray length for each of the 4 directions. When we get our actor inside the game, we'll look at how this actually looks. You'll also notice that as I'm editing these properties, our save icon up here has turned red. This tells us that we have not saved our content yet. Once we click it, it will return to white. By design, your editors will not autosave, and if you play your scene before saving, your changes will be lost. So make sure that you save whenever you're about to play your scene. The next section is the actor's stats. These are sort of like local variables. Here we can add a float for its health points remaining, we can add a boolean for whether or not it's done a double jump, and we can add a string for its name or some other property. For now, we'll leave these blank and we'll revisit these soon. You can also attach particle effects to your actor. If you look in the left, we'll see a folder here called particle effects. All we need to do to attach a particle effect to an actor is to drop a prefab of that into this folder. We can also attach weapons. Later in this video, we'll look at the weapon studio, and then we'll return to this section. The next section is interaction events, which we'll look at later. The next section is children actors. Here we can apply another actor to act as a child to this actor. The bulk of the actor's behavior will exist here in this page in the state machine. Right now we have no states, but we can add one by clicking Add New State. Here we'll call this new state idle, and we'll click Add State. We now have a floating box here indicating this state. We also have new tabs on the left for this state's properties. The first tab here is State Properties, which allows us to choose a behavior class and then define the properties for that behavior class. Here we have it set to idle, but we can change it to Move Ortho, which has different properties, Point to Point, which also has different properties, Side View Jump and Side View Fall, and Sine Wave. Each of these state behaviors has their own set of properties. We'll leave it on idle for the idle state. These 6 state behaviors that are included within the Boomerang 2D framework will cover most of your cases. However, if you wish to create your own state, it's pretty simple. We have a folder here called Custom Scripts, and inside of it, we have a folder called Actor States. All that you have to do is write a script that controls the behavior of that state, and once you do, you drop it into this folder, and it will appear in this dropdown. We'll talk more about creating your own scripts and events in a future video. For now, just understand that you can do that. The next tab is our transition triggers. We'll look at this after we've created another state. The next one down is our animations. This drop-down box will include all of the animations that we've configured for this state. We can create a new one by clicking this plus icon and naming it. I'll call this Idle Right and click Create. You'll see that we now have one frame of animation, and once we do, we'll see a preview of that animation over in the state machine. We'll talk about these properties a little bit later, but for now, let's look at the frames. When we look at our sprite sheet, we have 2 frames for our idle animation where he kind of rocks in place. So we'll create a new frame here. As I click the buttons for each frame, you'll see that the frame ID header is updating as well. For the first frame, we'll give it a duration of 0.3, and we'll use sprite frame 0. Sprite frame 0 is the first sprite frame that was chopped up when we imported our sprite sheet. On frame 1, we'll do the same with a duration of 0.3, and we'll use sprite frame 1. You'll see now our animation is toggling between sprite frame 0 and sprite frame 1. The next section here is our bounding box properties. You can see that our bounding box is not quite aligned with our player, and so we can update it for this frame. We know that we want it to be 16 by 16, but our bounding box offset looks like it should be a little bit lower. Once I do, you'll see that our bounding box is flipping between each frame. If we go back up to frame 1, our bounds offset X is still set to 16. When we set this to 0, it will now be in the same place for both frames. It's important to know that each frame of animation has its own bounding box properties. However, they don't have their own bounding boxes. When we created a bounding box here, we said that we only have one bounding box for this sprite. All that's happening in the animation is that we are defining the properties of that one bounding box that we've already defined. Because the bounding box's properties is set to each frame individually, we can add some advanced behavior relatively easily. For now, we'll leave it just like this. Finally, we have a section down here called Play Conditions. If we want our player to look to the left when the left input key is pressed down, we don't want to have to create a new state for idle left. All we want to do is create a new animation for idle left. Let's go ahead and do that now. We can do that the same way by clicking the plus icon and typing in idle left, or we can clone this existing animation, give it a new name, like idle left, and click clone. Now both animations will have the same properties. All of the properties are the same with one exception. Here, if we click the flip horizontal checkbox, we'll see that this frame of animation is now flipped horizontally. We'll go to the next frame of animation and check it there. We now have two animations set up for the idle state, idle right and idle left. So how does the Boomerang framework know which animation to play? Well, we do that down here under play conditions. We'll click this plus icon to add a new play condition. And here we'll have a trigger class and some properties for each trigger. If we click this drop down box, we'll see all of the trigger conditions that we can use. In here we have quite a few options. For example, is grounded, is on screen or is off screen, the result of a random number, whether it's hit by another actor's raycasting, how long we've been in this state, and much more. Here, we know that we want to face left when the actor is facing left, and so we'll use the trigger condition, facing direction. Each trigger class has its own properties. For example, if we look at the X position, we can see that we have properties for comparison and value. If we choose the trigger class user input down, we'll have options for the input type and the input value. We're going to use facing direction, and we're going to say that the facing direction is left. With this play condition, we've told the Boomerang 2D engine to play the idle left animation when our facing direction is to the left. You'll note that under idle right, we have not set a play condition. You can manually put a play condition saying to use this when our facing direction is right. However, you can also leave it blank. The animation chosen to play while you're in this state will be determined by the last animation in this list that has not had its play condition met. In this case, that is idle right. Because the idle left play condition does not equate to true, this animation will not have a chance to play, and will default to the idle right. We can include multiple play conditions for this. The way that this will work is like an AND and OR system. We have this box here for the one that we've already created. If we add another condition, for example, let's just say time and state is greater than 0 seconds. Now we will look left if our actor is facing left and we've been in the state longer than 0 seconds. We can add another group of play conditions by choosing this plus icon, and let's just give it some arbitrary things. Overlaps tile flag, let's just say enemy, and then we'll add another one, is grounded. These are entirely arbitrary and you wouldn't actually want to do this for this specific case. But I want to make the point that here we have two boxes that include multiple trigger conditions. The way this will work is if both of these conditions are activated, or if both of these conditions are activated, then we'll be looking left for this animation. Generally, you'll only have one set of conditions, but it's important to know that these act as ANDs inside these boxes, and multiple boxes act as ORs. Let's go ahead and delete this second set of conditions, and we'll go ahead and delete the second condition within the first set. Finally, let's look back at the top at these values that we skipped over. The first thing we'll talk about is loops indefinitely. If we uncheck this, our animation will no longer loop indefinitely while playing. We'll get an option to choose how many loops it will play, and which frame of animation to end on. The next one is called bound to global time, where normally when you enter the state, the animation will start on frame 0. However, with this checked, the animation will start in relation to when the game started. And finally, we have an option called Start on Existing Sprite. If the previous state had an animation that was using some of the same frames as this state's animation is using, it will start automatically on the same frame that the last state's animation ended on before transitioning to this one. Now that we have animations set up for our idle state, let's look at the next tab, Sound Effects. Here we can add a sound effect by clicking the plus icon, and then we can add sound effects to our sound effect pool. This first box is the name of our sound effect. Audio files are automatically registered simply by putting audio files into the Content Audio folder. Background music should be imported as MP3s, however sound effects should be imported as WAV files. MP3s take a little bit of time to process, and a WAV file is played instantly. Because MP3s play slower, they don't quite work for our sound effects, we'll have a delay. We want our sound effect to execute as soon as we enter this state. For example, if you press the jump button and your character starts to jump, we'll want to play a jump sound effect at that moment, and not a moment later. We can reference these sound effects simply by copying and pasting their name. Here we have a sound effect called Demo SFX Jump, so we'll copy this and put it into our pool. We can choose the volume, which is a value between 0 and 1, 1 being the loudest. We can also set our start time, which is the amount of time after we've entered the state. A start time of 0 will tell this sound effect to play as soon as we enter the state. However, if we were to set our start time to 60, it will play after we've entered our state 60 frames. The next property here is loops. If we choose loops, it will automatically play this sound effect over and over and over while we're in this state. If you had a running state and you wanted a sound effect like chuk 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 while you're in that state, we'll want to check this loops option. Finally, we have an option here called kill on state exit. Kill on state exit will tell the sound effect to stop as soon as we exit this state. If we uncheck this, the sound effect will continue to play until its natural end even after we've exited the state. We can also add multiple sound effects to our pool. Once we add multiple sound effects to the pool, we'll have a new option here that says play random. Suppose we're in a running state and we have 3 different footstep sounds that are at different varying pitches and speeds. With play random, each time it will choose one of the random sound effects in the pool when we loop it. If we uncheck this option, it'll play each sound effect in order and then loop from the beginning. For the idle state, we probably don't want to have a sound effect playing, so we'll go ahead and delete this. We'll now take a look at the next section called modification triggers. Some states might have special functions. For example, the idle state has a function called flip. Here, we can click a modification trigger to call this function flip and add a condition. Here, we'll say that a time in state is greater than 10 seconds, then we'll execute this function called flip. All that this function does is flip the facing direction of our actor. Finally, we have weapon triggers, which we'll look at more in depth later in this tutorial when we look at the Weapon Studio. Finally, we have entry events. This will be a drop-down box, and we can create a new entry event. This will be an event that is executed every time the actor enters this state. If we click the plus icon next to events, we'll see something similar to what we see when we add triggers. We have an event class, and each event class has its own properties. For example, this event class called background music play has one property called music name. The event start time is the delay that this event will execute after entering the state. In the same way that we have set up our sound effects, we can just grab one of these audio files for our background music and paste it right into here. Now, whenever the actor enters the idle state, this background music will play. We have a number of events that we can do. For example, background music stop, change our facing direction, change our map layer, kill the actor, load a new level, save our game flags, set our velocity, and more. We can also set the event to only execute if certain conditions are true when we enter this state. For example, we can have this play a sound effect only if we enter the state when we're facing right. We don't want any events to execute on this, so we're going to go ahead and delete this event. You can add as many events as you'd like to each state. Now that we're done looking at all the properties that we can assign to our states, let's go ahead and create a new state. This time we're going to create a walk state. I'll go ahead and set this up using the Move Ortho behavior class. I'll leave the default properties for now. I'll also set up an animation. You'll see that our bounding box is flipping left and right, and we have to set that every time we create a new frame. We can circumvent that by going back to bounding boxes, changing our default properties, and selecting set to all animation frames. Because these are now the new default properties, whenever I create a new frame, this is where the bounding box will be. The walk state is now set up with its animations. We don't need any sound effects, modification triggers, weapon triggers, or entry events for this state, and so I'm going to go ahead and skip past all that. The reason I wanted to set up the second state is to show you how transition triggers work. We'll select our idle state and choose a tab for transition triggers. Here, we'll have 2 main tabs up here, static and random. We'll create a static transition, and we'll transition to our walk state. Click this plus icon to create the new transition. We'll go ahead and add a condition to this walk state, and it works exactly the same way as the triggers for our modification triggers, our animations, and our entry events. The trigger that we want to use to transition from our idle state to our walk state will be when the user inputs left or right on the control pad. To do this, we'll use the trigger user input held, and we'll choose an input value. Here we'll choose axis and horizontal plus. We'll also create another transition in the exact same way, and this time we'll use horizontal minus. Here we'll transition into the walk state if the user either holds horizontal to the right or horizontal to the left. When we looked at the play conditions for our animations, you'll remember that each of these boxes represents an AND set and multiple boxes represent OR sets. So here, we'll be transitioning into the walk state when the player presses right on the horizontal stick or presses left on the horizontal stick. We'll also want to transition from the walk state back into the idle state, so we'll create that new transition now. Here the condition will be if the user is not holding any input. So we'll use the trigger user input not held. We'll choose axis and type in horizontal plus. And we'll add another condition, user input not held, axis horizontal minus. This way we'll transition back to the idle state when the user is not pressing to the right and the user is not pressing to the left. Now we probably want to see how our actor actually functions in the game. So we'll go to Tools, Boomerang 2D, Map Editor. I've already created a tutorial map for this use. I'll go over to here, I'll choose my tutorial player, and I'll add it to the main layer. In a future tutorial, we'll cover the map editor and the tileset studio together. You'll remember from the Getting Started video that our Start Game script will load a map automatically for us. Our map is called Tutorial Actor Map, and so we'll just change this to Tutorial Actor Map. And now we'll press play. You can see that our actor starts in the default idle state, and when we press left and right, our character will move left and right. You'll see that as I let go of the left and right buttons, we'll return back to the idle state. That's all that it takes to create an actor within the Actor Studio. I know that there's a lot of properties here, but once you understand what they're all for, it's both easy and fun to create your own behaviors. This actor would probably want more states to feel more refined, such as a fall state and a jump state. You'll notice that we didn't fall off the edge when we walked off of it, and that's because we didn't set up a state for it. One of the steps that we brushed by earlier is the interaction events. Let's add a new event by clicking this button. Here it's an unnamed event. We'll just call this Test Event. There are 3 columns. The first column is our actor filter conditions. The second are trigger conditions, which work in the same way that we've seen previous trigger conditions work, and events that will execute when these 2 columns are satisfied. So let's take a look at actor filter conditions. Let's click the plus icon here, and you'll see that we now have a new drop-down for an actor filter condition. Let's just choose is grounded for this example. You'll see that we now have a box for is grounded, and at the bottom we have match conditions. Here it says execute if matching actor count is less than or equal, greater than or greater than this value. What this is going to do is look at our scene for all actors and count the ones that match these conditions. Let's set this to execute if matching actor count is equal to 1. And then let's add an event. Here we'll just use the event debug log, which will log out some information for us. We'll just type in the word test for our message and hit save. Now let's look at what happens when we play. If we look in our console, we'll see the debug logs for test are increasing rapidly on every frame. Let's move our character off of this platform so he is no longer grounded. And see, now that this character is not grounded, our test count is not increasing any longer. That is because this event will only execute when these conditions are met. If we have exactly one actor in the scene who is grounded, then we'll debug log test. We can add another actor filter condition, and we'll say current state is equal to idle. Now, this event will only happen if we are grounded and idle. Let's go ahead and save and play again. You'll see that our character is in the idle state and our test count is increasing. However, once I start walking, our test count no longer increases. The same is true when we go off the ledge because we're not grounded anymore. We're still in the idle state, but we're not grounded, and so our test count does not increase. Let's add a trigger condition. Let's add user input down. We'll choose a key, and we'll just use the Y key. Let's save this and watch what happens. You'll see that we're getting no test debug logs outputting to our console. We are in the idle state, and our actor is grounded, and so our actor conditions have been met. However, our trigger conditions have not. So I'll press the Y key. You'll see that every time I do, the test increases by 1. Interaction events have quite a bit of power. Using these 3 columns, you can do quite a bit. For example, suppose you're locked in a room with locked doors, like in Legend of Zelda. You can use an actor filter condition set to determine if there are no enemies left in the room and then execute an event that will unlock the doors. For now, let's go ahead and take a look at the demo character that comes with the Boomerang 2D framework. You'll see that this actor has a much more complex state machine. We have states for things like idle, fall, wall grab, jump, duck, and attack. Let's take a look at how this actor has implemented some of the techniques that we learned when creating our own actor. If you select a state, it will only show you the transitions into and out of that state. If you select no states, you'll see all of the transitions that are available in your state machine. When we click on idle, we can see that we can transition from idle into jump, into fall, into climbing ladder, into walking, into attacking, and into ducking. Let's take a look at some of these transitions now. Here we have a transition that moves into the walk state if we're pressing right, and neither of the HUD objects are displayed. We have another one that transitions into the walk state when we're moving left. We have one that transitions into the jump state when we press the A button, one that transitions into the fall state when our actor is not grounded, one that transitions into the duck state when we're pressing down, and one that allows us to climb ladders if we press up on the D-pad, and we are overlapping a tile flag set to ladder. You'll also notice that we have two bounding boxes set up for this actor. We have one main one that has the default flag set to player, and a second one where the default flag is set to damage from player. Let's take a look at the attack state and the animation for it to see how that works. Here you can see we have two bounding boxes. The one on the right is the one with the flag damage from player. You'll see in our idle state, we don't have that bounding box. If we scroll down to look at our bounding boxes for our idle state, the main one is enabled. However, the second one is not enabled. This way, our bounding box will only exist when we're in the attack state, and the animation allows for that. Let's take a look at interaction events. Our first interaction event is called Bonk Head. It has no actor filter conditions, but it does have two trigger conditions. Here we have the trigger class for current state, and we're checking if we are in either the fall state or the jump state. We're using another one called distance to solid value. We'll get the distance from our actor in the up direction to a solid object, and if that value is less than or equal to 0, then this trigger will result in true. If both of these triggers are true, meaning that we're either falling or jumping and we have reached the top of a ceiling because our distance up there is 0, then we'll execute an event. The event that we're executing is called set velocity. Here, we'll tell it not to update the horizontal velocity, but we will update the vertical velocity to set to 0. This will automatically negate any upward velocity our actor has. When we look at our next event, take damage, we are checking if our bounding box with the player flag is overlapping another bounding box with the damage from enemy flag. If that's true, then we're going to change into a different state, knock back air. We'll then set a game flag for how much health points we have, and then we'll spawn an actor and we'll create a little explosion at the point of impact. Let's take a look at this knockback air state. Here you'll see that no states transition into the knockback air state. That's because this is done with the interaction event. Let's look at the entry event for it. We've created an entry event that has two parts to it. The first part sets our velocity to 0 in both the horizontal and the vertical directions. And then we set a sprite shader for flickering. We have a transition set to knockback fall if our vertical velocity is ever less than or equal to 0, and another one if we ever hit the roof, in the same way that we saw in interaction events. When we look at knockback fall, we can transition into two separate states. One is knockback rest, and the other is dead. We'll transition to knockback rest if we become grounded, and our player HP is greater than 0. However, we'll transition into dead if our player HP is equal to 0 and we're grounded. We have an interaction event here called reload level that determines if our player is in the dead state and we've been in that dead state for 2 seconds, we'll automatically reload this level. We can also throw bombs left and right, and this is done by checking how many bombs we already have on screen, and if that count is less than or equal to 1. In this way, we can never throw a bomb if we already have 2 bombs already on the screen. We'll also use trigger conditions to make sure that the player has just pressed the Y button, that we're looking left, and the flag is set to allow them to throw bombs. And if both columns are true, then we'll execute the event to spawn an actor, we'll choose our bomb, and we'll set some position properties. You'll also notice 2 things. We have a field called effects. We'll either affect this actor that's executing the interaction event, in this case the demo player, or the found actors. If we were to change this to found actors, instead of the bomb being thrown from the position of the player, a bomb will be thrown from the position of every other bomb on the screen. You'll also see that we've used the game flag trigger in a few different places. Let's take a look at game flags. We do that by going to Tools, Boomerang 2D, Game Flags. These are sort of like global properties. Here you can see that our player HP is a float, and we have all of the different properties that our player can do, such as can punch, can wall grab, can wall climb, can double jump, and can throw bombs. Here, if that global game flag is set that we can throw bombs, then we'll allow the player to do so. The reason that we've set these as global game flags is because we want these properties to persist when our player enters into a different map and is technically a new actor. However, actors also have their own stats. Here, I've created a stat for walk speed. I've also created a stat for total jumps. Total jumps is a stat that will reset to 0 every time our player is grounded, and every time we jump will increase. Once we have the double jump ability, we'll be able to tell if the player has already jumped twice while in the air. We'll look at the fall state and see that we have a transition into the jump state. When we scroll down and look at that transition for the jump state, we're looking at the trigger that has stat float value, total jumps is less than or equal to 1. If that's true, and the player presses the A button, and the global game flag can double jump is set, then we'll transition into the jump state. When we look at our jump state, there's an entry event that increases the total number of jumps. After you finish watching this video, I strongly encourage you to take a look at this demo player inside the Actor Studio and check out the different states. In other frameworks, there might be a checkbox for your player character that says can wall climb or can double jump. You'll note that the main difference between the Boomerang 2D framework and those other toolkits is that there is no automatic option to allow for double jumping or wall grabbing. Instead, all of this is done logically, almost like building blocks from Legos. You can see that we can do a wall grab simply by checking if our right direction to solid is less than or equal to 0, our facing direction is right, and we're holding right, and we have the ability to wall grab. Boomerang 2D is set up this way to allow a wide variety of versatility. It may be a little bit more complex to set up at the ground, but you have much more control over it. You won't have to email anybody to request features or functionality, you just make it yourself. The nice thing about this too is that you have complete control over how you'll create these behaviors. Remember earlier that I mentioned that we can write our own behavior class for a state by simply dropping it into the folder Actor States under Custom Scripts. You'll notice that we have some other things here too. We can create our own actor events, your own actor finder filters, triggers, camera states, game events, and more. We've looked at everything that actors can do, with the exception of weapons. So let's go ahead and look at that now. We'll open the Weapon Studio by going to Tools, Boomerang 2D, Weapon Studio. We'll create a new one. We'll just call this Tutorial. The first thing that we need to do for our new weapon is create a new melee strike. Once I click the plus button, we'll get a new strike button here. We can load a preview sprite by clicking this button down here and choosing our sprite. I'll choose Demo Player 1. On the right side, we have all the properties for our strike. We have a base class, which we can have as either a box strike or a wedge strike, and the start time. We also have a list of actions. Let's create a new action by clicking the plus icon here. Each action has several properties. We have the duration of our action, the easing mode, the beginning state of our action, and the ending state of our action. Let's set our duration to 1. We'll also set our width to 0.25 on both the start and the end, and we'll set our height to 1. The green shape is the shape of our melee strike. Let's start our angle at 180 degrees and end at 90 degrees. Now our weapon is animating from 180 degrees to 90 degrees. Let's make our weapon go from 180 to 0, and let's make the length of our sword a little bit longer. If our sprite sheet had an animation of our character holding a sword and slashing in this way, we can use the Weapon Studio to create a bounding box that will match the pixels of that sword. We can also add another action. Here we'll set this duration to 2. We'll start with the ending values of our previous strike. Now over the duration of 1 second, we'll do the swiping action, and then over the duration of 2 seconds, reduce its size down to 0. We can add as many melee strikes to this weapon as we'd like. So let's create a second one. This time we'll use the wedge strike. Let's add an action. We'll give it a duration of 2. We'll set its radius to 1 and its width to 360. Now we see that while we have the swiping animation, we also have a circle animation for this wedge strike. A width of 360 degrees will turn our wedge into a circle. However, if we had this set to 45 degrees, it would be a 45-degree arc. Let's leave its width to 360 and its angle to 0 and increase its radius over time. And we'll start with a radius of 0. Let's set our easing mode. We have a lot of different options to use. The one that I'd like to try is elastic in-out. You can see how that changes how the animation plays. This is bounce, ease in and out. You can see that we have a bounce when it starts and a bounce when it ends. This wedge strike could be useful for attacks such as an explosion. Let's go ahead and save our weapon. Now that we've saved our weapon, let's go to Tools, Boomerang 2D, and Build Reference Database. Now that we've done this, we can go back to our Actor Studio. If we look at the attached weapons, it says that no weapons have been created. We need to manually update this editor to tell it that changes have been done in other editors, and we do that by using the refresh button. We can now attach the weapon Tutorial with this plus icon, and now it says that our attached weapons includes Tutorial. So let's go ahead and save this. We can now go down to States, choose our idle state, select Weapon Triggers, and we can add a weapon trigger to our tutorial weapon. We can adjust some of the properties for that weapon, including its horizontal and vertical orientation, its offset, its scale, and its starting rotation. Let's add a condition for invoking this weapon. Here, I'm going to just do user input down. I'm going to choose the key, the U key. As long as our character is in the idle state and I press the U key, our weapon will invoke. Let's see that in action. Let's open our scene and select our player. Now when I press U, we'll see the weapon fire. Here I've opened the demo enemy car, and I'm going to go to the interaction events. We can create a new event called Hit by Weapon. We can add a trigger condition and use the trigger Overlaps Weapon Collider. We can set the name of the weapon and add an event that kills the actor. There's a lot that you can do with the Weapon Studio, and I encourage you to play around with it. If you need any kind of bounding box that isn't a perfect square and isn't aligned orthographically, the Weapon Studio is probably your answer. And that's it for the Actor Studio. I know that this was a big one, and there was a lot to cover, but the more you play around with it, the easier it'll get. Thank you for watching this tutorial, and we'll see you in the next one.